Here we go. Star 6 worked. All right.
Take it
All righty.
away.
Good afternoon. Sorry, what was that?
Sorry, you are way ahead of me. Take it away. Thanks for being here.
All right. Good afternoon, everybody. My name is Patrick Mills, and I'm an engineer with the Confederated Tribes' DNR Energy and Environmental Sciences program. I'm going to be talking about the renewable energy on the Umatilla Indian Reservation. So I'm going to start with the conservation of energy and how that applies to transforming energy in the many different forms that energy can take. And then I'll be talking a bit about the energy resource potentials of the Umatilla Indian Reservation with examples. And then finally, I'm going to be ending on the strategic energy plan. It's a project that we've been working on pretty diligently lately, and glad to tell you a bit about that. So to start with, the first law of thermodynamics is the conservation of energy. And basically what that means is that energy is neither created nor destroyed, but it can be transformed from one form to another. And so these figures down below, that is what I'm showing. So to start with the top left image, we have a biomass energy facility that is located in John Day, Oregon. And essentially what we're doing is taking chemical energy that's in the biomass and we convert that to thermal or heat energy. And they're using that to heat their high school there with a lot of success. And then next, the windmills. A lot of people are familiar with those. Basically what's happening is kinetic energy from the wind is being transformed into electrical energy. And then in the next figure to the right, you see a helicopter that's flying. What's happening is chemical energy is being converted into mechanical energy. And also in that image, we see a picture of a dam. And that is the potential energy of the water being converted into electrical energy. And moving down below, the picture of the solar modules, we have solar energy being converted into electrical energy. And finally, that lower image on the right is a geothermal power plant, where they're taking geothermal energy, converting it into mechanical energy, and finally into electrical energy. It's being used by thousands of houses. So energy surrounds us. I mean, it's really a part of our everyday life, whether you realize it or not. It is very foundational to life and really everything that happens in the universe. Whether it's solar, radiant solar energy coming from the sun, or electrical energy being discharged during a thunderstorm, or the geothermal energy inside the earth. There's a ton of it there. People often refer to that as the heat beneath your feet, but there's vast amounts of heat energy trapped inside the earth, and some scientists actually estimate that the inside of the earth is actually hotter than the surface of the sun, surprisingly. So yeah, energy is very, very vital and essential role to everything that happens. And that really does include, for example, adenosine triphosphate, which is chemical energy used by all life forms, the bonding of individual atoms to form bigger molecules such as water, or even driving to work or riding your bike or snowboarding or skiing. Anytime you have movement or an elevation change, you are dealing with mechanical energy. And so there's kinetic energy and also potential energies that are part of mechanical energy. So now moving on to the more site-specific resource potentials of the reservation. First one I want to talk about was the solar photovoltaic resource, and that's the resource that's needed for generating electricity using a solar panel. That resource is pretty much uniformly distributed across the entire reservation. And on an annual average, we have about 4.2 kilowatt hours per meter squared day. And so keep in mind, that's an annual average. During the summertime, it's quite a bit higher, and in the wintertime, it's quite a bit lower. But averaged out over the entire year, we have about 4.2 kilowatt hours per meter squared per day, which is pretty good. It's not the best. If you move further south, like to Arizona or New Mexico, the solar resource increases. But still, it's very viable here on the reservation. And so a project the EESP was involved with a few years back, and is actually technically still ongoing, was the construction of a solar PV array behind the field station. That's shown in the image below. And we constructed that in 2018. And since then, it's generated more than 341 megawatt hours of alternating current energy. And that's as of today. And what this equates to, this amount of energy, if it had been generated from fossil sources, it would have released more than 51 tons of greenhouse gases. And so putting this in the context of climate change, what these clean renewable energy systems do is they prevent the release of greenhouse gases that would have otherwise been released if the energy had been generated from fossil sources. And real quick, I'm going to see if I can bring this up. Stand by. All right, can everybody see that is the real-time energy generation of the solar panel? Is that being shown right now?
Yes, we can see it.
Perfect, okay. So the overcast is getting a little worse here. Normally, if this was a really sunny day, the AC power now that you see would be closer to about 90 kilowatts, and that would be how much energy generation was taking place instantaneously. But yeah, this is a really nifty tool. It's available. Anyone who wants to check this out can follow the link. I believe it's on our EESP website page. Yeah, production data is available on here, and it's just a really handy tool for seeing how well our solar system is performing on a day-to-day basis. Okay, I'm going to switch back real quick. All right, now moving on to the wind resource potential of the reservation. The wind resource is needed for spinning wind turbines that generate electricity. And this resource is very site-specific, unlike the solar resource. It's highly dependent on topography as well as other factors. And so down below in this figure, you can see that as we move east into the higher lands of the reservation, that is typically where we see a better potential for generating electricity from the wind resource. And so far, the EESP, as far as I'm aware, has not been involved with the wind project, but we do have the wind turbine that was put in at TCI. So there has been some work done in this field. Then next, I wanted to talk about a few of the many other renewable energy resources available to the tribes here on the reservation. A few of those include biomass, which can be used for generating baseload heat and or power. The U.S. Forest Service actually recently approached us. They want to provide the tribes with biomass for doing an energy, some sort of renewable energy project with it. It could either be, generating heat or also heat and power. So the figure down below on the left is an image of a biomass boiler facility, and that is heating a number of buildings. And also, we have an opportunity to do pump storage hydropower projects, and those are primarily for energy storage for grid balancing. And I don't think we've done a project here on the reservation as of yet, but there has been discussions of it. And then in the city of Pendleton, the water municipality actually has an aquifer storage and recovery system. And then also Madison Farms near Echo, Oregon, have an aquifer storage and recovery project completed. And so those would be examples of pump storage hydropower. And I just want to point out that resource assessments and feasibility studies, if we wanted to pursue projects like these, we would need to complete those first. And that's really how you determine if a resource is developable. And then a few more renewable energy options available to us here. Renewable hydrogen, you maybe have heard me talk of that in the past, but basically that can be used for transportation and for grid balancing. hydrogen can be produced from water using an electrolyzer, and as long as the electricity used in that electrolyzer comes from a renewable source, you can say it's renewable hydrogen. So it can be truly carbon-free and not emit any greenhouse gases. And then once you have that hydrogen, it can be recombined with oxygen in a fuel cell, for example, to generate electricity. And so when cars use hydrogen fuel cells, the only emission is water vapor, which is pretty cool. And then also geothermal. I know we have a geothermal resource here. It's just a matter of how viable it is. And so resource assessment is underway for that. But if we are to proceed with a geothermal development, basically what we'd be getting is baseload heat and or power. And so if we wanted both heat and power, you know, for example, you could heat a bunch of greenhouses, you could do district heating, you know, or we can just generate electricity and power a bunch of buildings and homes that way. So then the figures down below, I just wanted to demonstrate that hydrogen is really central to the renewable energy economy. That figure shows how it's really connected to most everything in our current energy sector. And then that figure to the right of that is actually the Pepper Mills geothermal system. So the 2.1 million square foot Pepper Mill Resort and Casino in Reno, Nevada is actually heated 100% using geothermal energy. And so this very well could be doable here on the reservation as well. We're looking into that. So a little more on geothermal. The resource assessment that is currently underway started a few years back, and phase 1 was completed in 2018. Phase 2 is still underway, and the image that you see below shows a few stars. Those are the primary drilling targets that we're looking at. And during the next phase of the project, we would like to install temperature gradient boreholes to measure how the temperature changes as you go further and further down. And we would like to install those to depths of roughly 5,000 feet, which is a pretty lofty goal, but I think the scientific and project development data that we could get from that would be invaluable. And so yeah, basically this project, this resource assessment project, is going to provide us, the tribes, with the data for determining the feasibility of developing a geothermal power plant. All right, now onto this strategic energy plan. Just to give you a brief overview of it, this plan will establish the CTUIR community's energy vision and guide for the organization's energy conservation and generation efforts for years to come. This is sort of the master plan for how the tribes want to handle energy-related topics and implement projects over time. This figure is basically the process that we've chosen to follow. It's based on the DOE Office of Indian Energy Handbook for Tribal Strategic Energy Plans. And just to give you an idea for where we are at in this process, we're somewhere in here, if you can see that, just below form leadership team. We're in the process of hiring a subcontractor to help us with all this other stuff. So more on this to come soon. And I think we can, at this point, say confidently that a survey is going to be released early this summer that's going to enable the community to help us form this energy vision. That's really the driving force for all this other stuff. And a little more on the strategic energy plan. All available energy options are going to be provided for the tribe's consideration. We're going to have a really exhaustive list there to start with, and then kind of whittle it down based on, you know, the local preferences and what is actually achievable. Once the plan is complete, the resource assessments and feasibility studies will be completed for preferred energy options. So not every energy option is going to be pursued. There are some that are not favorable here, but for some, such as the geothermal resource, we definitely want to take a closer look at those to see if they are in fact developable. And then, so once you complete your resource assessments and feasibility studies, at that point you can determine if you want to proceed with resource development. And so the figures down below kind of illustrate this. You know, we start here on the lower left, and you know, first you have to I guess, recognize that there could be a potential resource available. And at that point, you can go and do your resource assessments and favorability studies. And that's where we're at with the geothermal project. And then finally, once we know if the resource is developable, then we would proceed with the next stage of development. And what you would essentially end up with is, a geothermal power plant of sorts. So just a quick example of what we got going. And that is all I have for now. Are there any questions?
So now is an opportunity to ask Patrick clarifying questions. We want to save some of those more discussion-heavy questions for the end. I know, Patrick, I have questions for you about the ability to use that hydro pump kind of storage with the wastewater recapture system that Public Works and Planning has been kind of trying to put together, but that's a more discussion question. So if anybody has any questions for Patrick, now would be a great time to ask them. All right, hearing none, I think, thank you so much, Patrick. It's really great to hear the energy generation potential. Do you have any closing?
Anton, can you hear me?
Yes, we can hear you, please.
Okay, yeah. And I just been following the earlier, the presentation and the maps that are being used, and the map that reflects the reservation after it was reduced down from the 512,000 or 300 square miles. But I'm just wondering, when you're doing an assessment of energy potential, is it just within that within the reservation, or is it including the seeded areas, Hanford and McNary Dam and those places like that? Are staff looking at that? The whole picture, the big picture, that made the big picture, and then all the projects that go on within that. That's all.
Right, that's a very good question. I can say that for some of these resources, such as the solar PV resource, the data is already available. And so, yeah, we could easily say, in those other areas, what the resource potential is, but not for all of them. For some, wind, I haven't seen any data for that one. And then definitely not geothermal. We're, just focusing on the reservation. But yeah, great point. And I think that data on a broader area could definitely be valuable to the tribes.
I think.
Oh,